So this is the experimental setup for interplanar spacing of a diffraction film. You can see this is the diffraction film. So here we require traveling microscope for this experiment. Aim of the experiment is to calculate the interplanar distance of a cubic crystal using X-ray film. So we have used here the cubic crystal X-ray film. We have to find out the interplanar spacing. So here we require traveling microscope and structure of X-ray film as I shown. So here if we draw the diagram for the X-ray diffraction film, we can see here. So we have to find out here interplanar spacing between the lines. So first we need to find out the least count of the traveling microscope. Then whatever the wavelength of the X-ray, it is always near to 1 angstrom. So here the wavelength of the X-ray is 1.86 angstrom. In terms of meter, it is 10 to the power minus 8 centimeter. So if we take the traveling microscope, we come across two scales here. One is horizontal scale and one is the vertical scale. So here is the vernier scale. You should note down the main scale reading and then vernier scale reading, and if you know the least count, you can calculate the total reading. So first we should know the least count of the traveling microscope. So if we want to calculate the least count, we have to consider the vernier scale here. So if we take this line, that is what the 0.5, it has 10 divisions. So 0.5 divided by 10, how much? The smallest division is 0.05. So how many lines are here? 50 lines. So least count is given by 0.05 divided by 50. That is what the least count. 0.001 is the least count. 0.001 centimeter is the least count of this traveling microscope. If you calculate vertical or horizontal scale, the least count is going to be same. So here is the X-ray film for cubic crystal. Here we have the lines, different lines. So left, if we consider, there are 3 lines, 1, 2, 3. Right also 1 prime, 2 prime, 3 prime, and middle lines if you consider towards left 1, 2, 3, and if you consider towards right, middle lines 1 prime, 2 prime, 3 prime. So for each lines you should note down the main scale reading and vernier scale reading from traveling microscope. So we have to fix this to the base, this X-ray film. So first we need to focus on the any of the line, left or right or middle line. Then you should note down the main scale reading and vernier scale where it is coinciding. Use the least count value, calculate the total reading. I focused the traveling microscope on the first line of the left. So we have to note down here the main scale reading. So here it is around, the vernier scale is coinciding to the main scale at 13.7, around that value. Then you should note down the vernier scale line where it is coinciding to the main scale. You can use this magnifying lens to see clearly where the vernier scale is coinciding to the main scale. Okay. So here is the formula to calculate total reading, that is equal to MSR plus CVD into least count. So main scale reading is around 13.7. CVD, how much you get, put that and use the least count, 0.001 centimeter. So here is the tabular column, reading of microscope when focused on the left, middle and right. So first reading they also got L1 is equal to 31.7. So next L2, they are near values, they are because the lines are close to each other. So L3. So like that, go for middle lines, they got around 8.5 centimeter. So M2, M3 middle lines, right lines R1, R2, R3. So M2 middle lines, you have two different set here, M1 prime, M2 and M3 prime also you should note down. So you have to repeat the same procedure for calculating the total reading for middle and right lines also. So here is the tabular column, reading of the microscope when focused on the dot, left, middle, right. So left side L1, L2, L3, middle near to left lines M1, M2, M3, right side R1, R2, R3 and the lines near to R1, M1 prime, M2 prime, M3 prime. So once you note down these readings, you should calculate the value of A and B. So value of A is, that is from origin, A is equal to M prime plus R by 2. So middle lines near to right side M prime plus R. So R1 plus M1, R2 plus M2 prime. So like that you have to calculate 3 readings. That is we call that as value of A, and B, that is given by M plus L by 2. So we have to add L1 plus M1 and divide it by 2. Similarly 3 readings you have to calculate using this formula, that is the value of B. Once you get A and B values, you can calculate the distance from the origin O prime, that is equal to A minus B, that is equal to W. We can calculate once we subtract A and B values, A minus B, this column and this column. So we will get around 7.5. Next we go for the calculation of 2s, that is equal to A minus M prime or M minus B. If we calculate, we are going to get again 3 readings. So write down these values for M and M prime. Next we have to go for the calculation of angle theta, that is given by the formula 2 pi s into 57.04 divided by 2w. So w is given here, 2s is from this column. Substitute and calculate theta value for left and right lines. So once you calculate theta, you have to take the average of W. You will get 7.52 and mean of theta 25.42. So once you calculate angle theta using this formula, then we can calculate the interplanar distance spacing, that is given by T equal to lambda by 2 sin theta, where lambda is the wavelength of X-ray film, that is about 1.6 angstrom. So if we substitute the average value of theta from tabular column and wavelength of X-ray, you will get the interplanar spacing of a cubic crystal around 1.86 angstrom. Okay. So if you take the average value of theta from tabular column and substitute the value of wavelength of X-ray, that is 1.6, you will get the interplanar spacing, that is about 1.86 for a cubic crystal.